All right, so I'm going to start again. So obviously today our goal at the end is to graph the quadratics as well as find the solutions. And we're going to talk solutions first before we actually get into graphing. And that's where this discriminant comes in on the back of the sheet you have. So like I said, the discriminant is the stuff that's inside the root. It's the b squared minus 4ac. We're going to use that information to kind of help determine the number of solutions that it might have. When the discriminant is negative, when it's less than 0, it has 2 imaginary solutions, or you can write on here 0 real solutions. Our graph would look something like this, like if this were the axes. I'm going to make that a little more obvious. It would never touch the x-axis because the solutions are where the graph touches the x-axis, your x-intercept. So you might want to highlight that up there. The solutions are the same thing as your x-intercepts. So if you get a negative number in your root, you're not going to have any solutions. It's never going to touch the x-axis. If you get a discriminant of 0, like the one we just did on the homework, where you get a 0 inside that square root, that means that the graph has 1 solution, and it would look something like this, where it goes down, touches the x-axis once, and bounces back. And then the last scenario, if the discriminant is greater than 0, if it's positive, there's 2 real solutions. So your graph would look something more traditional like that. That's most of probably what you've seen before, where it's going to touch that x-axis twice. 2 solutions. So today when we're graphing, we're actually going to find the x-intercepts, the solutions for all the graphs that we do. But you can use the discriminant in here to help you determine how many there should be, because we're actually going to have to use quadratic formula and square roots today to solve as well. Okay? So flip the page now. Like I said, there's 2 ways of graphing. The first one we're going to do today is what's called standard form, which is what we've been working with anyways with quadratic formula. So this is what we call standard form. You guys remember that from yesterday. So all the graphs today that you're going to work with are going to be in standard form. And then tomorrow we'll talk about vertex form. Okay, so there's a couple things you're going to know that the equation tells us about standard form. So the first up is this leading number a, whatever's in front of a. If a is greater than 0, if it's positive, the parabola opens up. If that leading number a is less than 0, if it's negative, the parabola opens down. It's reflected and it's upside down. It points down. Okay. When it comes to the width, the number in front also tells us whether it should be a skinny parabola or whether it should be really wide. If the number in front, if that absolute value is less than 1, so if it's like a decimal, like 0.5 or 0.2 or 1/4, when it's smaller than 1, the parabola is wider than the parent function, that regular x squared. So you guys know what a regular parabola should look like. The smaller the number out front, the wider that parabola will get. Obviously, when it's equal to 1, the parabola is the same width as y equals x squared. And when you have a number in front like a 2 or a 3 that's greater than 1, the parabola gets skinnier. Skinnier, fit it in there, than the regular parabola. So you're not going to have to use a whole lot of that. If you took Algebra 2 last year, we did a ton of this kind of stuff, describing the transformation. Is it shifted? Is it skinnier? Is it wider? Is it reflected? I'm just putting this on here again for you so you guys kind of know, looking at your equation, hey, if I have a 2 in front for my a, my graph should be skinnier than the original function. So you kind of have a heads up of what your graph should look like. Okay? The first step of graphing all of these is going to be to find the vertex. When your equation's in standard form, this is your equation to find the vertex right there. X equals negative b over 2a. So if you read this, I'm going to put a star by it. To find the vertex, plug in x equals negative b over 2a. That'll get you your x value. And then solve for y. That'll get you your y value for your vertex. So we're going to go ahead and do that looking at example 1. So I've got f of x, remember this is the same thing as y, equals negative x squared plus 2x plus 3. So the very first thing I've got to find is the vertex. So I'm going to do negative b over 2a. Make sure you include the negatives. Don't punch this in all at once. You've actually got to simplify this to this. So we get an x value of 1. So that means your vertex is at 1 comma something. We got to figure out that something, so I'm going to plug 1 back in. Make sure you use parentheses, and don't forget the negative out front. And you can punch that in your calculator exactly the way it looks. And then you should end up getting 4. If you have a graphing calculator that you know how to utilize to help you with graphs, you can do so, but we're not really going to go over how to do that since not all of us have graphing calculators, very few of us do. But if you have it and you can use it to help you get some of these, that's fine. But obviously there'll be parts in here that you'll have to actually do by hand as well. So my vertex is 1, 4. So go ahead, I always plot that point first. 1, up 1, 2, 3, 4. And then since that's my vertex, that's the turning point of my parabola, it's also where your line of symmetry is, straight up and down. So I always draw a dashed line through the center, showing that that's my center, because in a second we're going to actually take some points and reflect them over. So right now, axis of symmetry, that's the next bullet point up on our chart up here. The vertical line passing the vertex, one we just drew, also has the equation x equals whatever negative b over 2a is. So the equation for that dashed line is x equals whatever this is here, which is 1. So your axis of symmetry is always an equation for a line. It's always x equals, and it's whatever the x value of the vertex is. It's kind of going back to like Algebra 1 there, of graphing vertical lines. Our equations are always x equals something. Okay. To find the rest of the points on the graph, this is what we do. Plug in next to x values. So whatever the vertex is, which in this case our x value is 1, we're going to plug in the next two x values, which are 2 and 3. And you just plug them in to your equation up here. So y equals negative 2 squared plus 2 times 2 plus 3. So I end up getting 3 there. And I get y equals negative 3 squared plus 2 times 3 plus 3. And I'll end up getting 0 there. The reason that we only plug in the next 2 to the right are because when I plot those 2 up 3, that dashed line is our symmetry line. So I can also take this and reflect it over on the left. Same thing with this one. 3, 0 is right here, reflected over here. And right there, I've got enough to make my parabola. Make sure you draw it so it covers the entire graph. And that's your parabola. Okay. We've got to talk domain and range before we get into the x and y intercepts part. Domain and range, this is going back to Unit 1. This is a nice kind of bringing this back right before your final exams. Domain and range, we're writing them in interval notation, just like what we did back in Unit 1. The domain for all of these, the good thing is these x values go forever to the left and forever to the right, so our domain is always going to be negative infinity to positive infinity. The range is what will not be that. The range will have an infinity on either end, but not both. This one, since the graph goes down, remember range is bottom to top. Our bottom range value is negative infinity. It goes up to a y value of 1, 2, 3, 4, and it actually hits that 4, so put a bracket around it. So I know it's been a little while since we've done interval notation with domain and range, but we've done it probably unit 1. When was the last time we did it? So here it is again. You'll see this obviously on your final exam next month. But just remember, brackets around the infinities, or excuse me, parentheses around the infinities, brackets around the point it actually hits. So it actually hits 4. That's why there's a bracket around the point it actually hits, parentheses around the infinities. Okay. The last two things we're going to find about this graph is the x and y intercepts. This one's nice because we can actually visually see where the x and y intercepts are. You might not be able to see them like this one, and we're actually going to then solve for them. But in this case, you can see them. The x-intercepts, there's 2. One right here at -1, and one right here at 1, 2, 3. The y-intercept is right here at +3. With that being said, though, I'm going to jump back up here and I'm going to highlight this. In this particular graph, you could see the intercepts. Pretty easy, write them down. When you can't see them, here's what you do. To find the x-intercepts, you plug in 0 for y. To find the y-intercepts, you plug in 0 for x. So you might want to jot this down. This is what you do when you can't see on the graph. How would you solve for it? You might use quadratic formula. You might use square roots. When you solve for y, it's just basic solving, just plain old algebra 1, 2-step equations, even 1-step equations. But for standard form today, the way we're going to do this one mostly is going to be quadratic formula. That's what we're actually going to do in example 2. Okay? But do you guys have any questions on the graphing part before I go on to the bottom one? The questions you're going to see on your test and quiz will look just like this, just with find the graph and then tell me these same 6 things over here. Okay. The bottom says without graphing, find both the vertex and the x and y intercepts. So we're going to not graph this, but we're going to find the intercepts in the vertex. So vertex first. I'm going to do x equals -b over 2a, which gets me -5/4. And leave it just like that. We don't need to make it a decimal. If you did, I wouldn't dock you points, but you can leave it just like that. So I'm going to grab a calculator here, because when you plug this back in, you're going to want to use your fraction button. So when you plug this back in, oh, I apologize, the second one. Thank you for catching that. So let's plug this in. I got 2 times -5/4 squared plus 5 -5/4 minus 10. Don't forget, if you have this old calculator, the fraction button's that ABC one right there. Hit equals. You can leave it as -10 1/8 if you want to, or if you hit second ABC, it'll make it a improper fraction. I don't care which one, -81/8. Doesn't matter. We're not graphing this, so it doesn't matter that it's an ugly number. Our vertex would be the point, -5/4, -81/8. So that's the vertex. The 2 intercepts, we're going to do the y-intercept first, because the y-intercept is always the easier of the 2. The y-intercept, take a look back up at what you highlighted. To find the y-intercept when you can't see it, plug in 0 for x, the other letter, and solve for y. So looking at this, you'll see why it's easy. If I plug in 0 for x in standard form, the y-intercept always ends up just being my c value because the first 2 terms just go to 0. So the y-intercept is -7. So that's not bad. y-intercept there. Now the x-intercept. This is where we're going to have to do a little bit of work. I should have left myself a little bit more room, but we'll fit it. The x-intercept, if you look back at what it says up top, it says plug in y equals 0, plug in 0 for y, and solve for x. So here's where yesterday's comes in. I'm plugging in 0 for y, and I have to solve for x. I can't use square roots, so hopefully you're looking at that realizing that looks exactly like what I have to solve in the quadratic formula. So let's do it. Negative b plus or minus the square root b squared minus 4 ac all over 2a. So when you punch that in your calculator, remember put the stuff inside the root in your calculator. 5 squared minus 4 times 2 times negative 7, and we get positive 81. So this is one that's nice because we know what 81 is, so we can break this down. So we'll actually get 2 x-intercepts that we can do. So if I did negative 5 plus 9 divided by 4, I'll get 1 as one of the x-intercepts. And negative 5 minus 9 over 4, you can just leave it. If you want to make it a decimal, that's fine. Or if you want to leave it as negative 7 over 2, that's okay as well. So those are your 2 x-intercepts. So your graph would touch at positive 1 and negative 3.5. Okay. What questions do you guys have right now? Okay, tomorrow we're going to do vertex form, which if you ask me is the easier of the two forms, so keep this somewhere safe for tomorrow. Grab your assignments. You're not going to do all the graphs today because obviously some of them are a standard form. So grab this and we're going to go through and circle the ones that you can do with standard form. Pretty much like the second half of this. So today I want you to work on 6, 7, 8, 9, 10, and 11. So 6 out of the 12. So 6 through 9, so basically 6 through 11. 12 and number 3 you could do as standard form, but you could actually also do them as a vertex form too, and I think that's the easier way of doing it. But if you wanted to try 3 and 12, you can also try those. Obviously, I think you guys can see the ones we skipped are the ones with parentheses. Those are what we call vertex form, and we'll talk about that tomorrow. Okay? So if you look at these, when you do this, like something like, I think this one, actually I'm not sure off the top of my head, but all of these, if you graph them and you find that you get a graph, don't write this graph in there because this might not be correct for this one, but if you get a graph of something like that, under x-intercepts, what would you write? Well, you would just write none. It doesn't touch the x-intercept, there's no solution, so you'd write none. So just watch out for those ones because there might be some like that. There might be some where it only touches once. If so, just do that. I'll take a look at my answer key and see, but if you can see the x and y intercepts, just write them down from your graph. If you can't, you would have to take this equation and solve like we just did in example 2. So obviously if you have to solve, you might need to attach a piece of line paper or you might be able to squeeze it in over here. It's up to you. But so start trying those. I know we don't have a ton of time. But so work on 6 through 11. What's up?
When it's negative, you're supposed to plug in the next 2x values. Do you go up or down?